Hi, this is Swapnil Bhartiya and welcome to another episode of TFR Insights. And today we have with us Julian Fischer, CEO and founder of Anynines. If you look at Anynines, it predates Kubernetes and it has been helping users embrace cloud-native technologies for almost 8 or 9 years now. So, Julian, can you talk a bit about the fact that as the adoption of cloud-native has increased, what unique challenges you face now as compared to earlier days when these technologies were relatively new and they were embraced by companies who were tech-savvy early adopters who were kind of willing to take risks that came with any new technology?
Well, in the beginning, as you said, there were the early adopters. In those times, all the technologies were already, well, let's say, interesting, and people were engaging with those technologies, such as Cloud Foundry and Bosch. In those times, we've already helped many clients to build their application development platforms. So over the last 5-6 years, many of these platforms have grown into large, substantial platforms where there's often thousands of virtual machines. Along that journey, these technologies have matured. So Cloud Foundry and Bosch, for example, they have been rock-solid companions, so to say. Now, in this entire technological digital transformation, let's say, there are always individual technologies uprising, and some are, well, let's say, losing popularity to some degree. So there are technological shifts happening while the overall challenge remains the same. So if you, for example, compare 2015 with 2020, in both years, the establishing application development platforms is what most large corporates now will have to do in order to get their IT departments up to speed. With these technological changes, they also come with challenges.
So when you talk about challenges, what I have seen that even if Kubernetes or Cloud Foundry, all these technologies are maturing, they are moving from evaluation phase to deployment phase. There are still a lot of challenges and problems that customers continue to face.
Well, interestingly, many of these problems have already been solved. It's not that each project is, well, let's say, absolutely new and there's much innovation required. The toolings to build modern application platforms are there. So if you look into, well, let's say 2015 versus 2020, as I said, the mission is still the same. The tooling has changed. And now imagine you are running a large corporate and you've invested into one particular technology 5 years ago or 7 years ago. Just to remind you, for example, about the OpenStack movement that has somehow, well, let's say, lost momentum. So during a digital transformation project, technologies change, and that also creates challenges. Beside of the necessity to keep up to date and adapt to new technologies, each individual organizations, the larger they are, the bigger this challenge is. They have to, well, let's say, enter a path of learning. They have to reinvent their own cultures. So when they've been, let's say, for example, organized vertically into different departments, they now bring together those departments into cross-functional teams, introduce agile software development methodologies, and along with that, lean product management and the necessary, or let's say, the prerequisite to bring these methodologies to success is also having a modern application development platform that reduces friction in deployment and provisioning of cloud resources. So whatever has been buying a hardware server in the past now is deploying a container. So you have to distinguish the two things. The first would be the adoption of a customer's digital transformation journey to the changing technologies, and the second is the journey of learning that each of those more conservative organizations have to go through.
We cannot talk about OpenStack without talking about also the hyperscale cloud provider and behemoth like AWS or Azure is there, and then GCP is there. So when these big players are there in the cloud native space, how does a company like Anynines differentiate itself from this big player? Because sometimes what we do see is that while these hyperscale cloud providers, they do have everything that you can get from them, but you don't almost need everything. And that the problem that you're trying to solve may be totally different than, one size fits all. So talk about how do you differentiate yourself?
Well, first of all, what's necessary to understand is that a lot of these large corporates on their path of digital transformation do not naturally approach large vendors such as AWS or Azure. They first try to solve these problems and these challenges themselves, digitally transform their own data centers. A lot of these companies, they do have their own data centers or established vendor relationships. So there is a certain resistance to change, and they are not freely running into the open arms of the large vendors. Now, the question is then, why didn't that succeed at scale? And OpenStack is a part of that journey. So there was a lot of hope that there will be a technology offering a similar abstraction like AWS did for virtual machines. Visualization has been a trend for over a decade, and in a consequence, somebody put basically an API on top of virtualization and offer that as a service. That's basically how AWS was born, and EC2. Now, every corporate who wants to increase the productivity and decrease friction in operations will have to go through a transformation, let's say applying a DevOps kind of model, or today look into containerization. The idea is always the same: is you have a workload that you want to operate, and you want to reduce the effort that's necessary to bring such software into operation, and also the efforts required to maintain it. And these on-premise scenarios often have been very complicated and problematic because there's either a commercial vendor that will ask a lot of license costs for software that will work, or you have to rely on an open source software such as OpenStack, which for many organizations were just too overwhelming. Many organizations did not really manage to get an OpenStack up and running in a way that it could be competitive in pricing. And that, let's say, disappointment of the initial expectations to OpenStack also opened the path for Kubernetes. So these corporate clients on the path having this experience, they have now two choices. Either they try a different technology, for example, Kubernetes, or they will then go to those large infrastructure providers because it seems to be the only thing that really works. And I think that's where Kubernetes gets a lot of momentum from, because you can't just go to the infrastructure provider like AWS and Azure and be happy as a large corporate. Why is that the case? Well, let's say you want to roll out a global product, and you then have to run a software workload across the globe. Your Chinese customers maybe have a stronger affinity and even legal requirements to run on top of Ali Cloud, a local infrastructure provider, rather than AWS or Azure. And in Europe or America, there will be a different provider with more affinity. So the problem of infrastructure agnosticism rises, which is, let's say, not very much wanted by the infrastructure providers themselves, which come with their own APIs and data services and so on. So you have a lot of heterogeneity across these infrastructures. And now Kubernetes seems to become an abstraction layer that allows you to describe a workload, and assuming wherever you go to, there will be a Kubernetes, so that there's some harmonization going on. This connects a bit to the idea that was underlying the technology called BOSH, known from the Cloud Foundry ecosystem. And companies like Anynines, to answer your question, we are actually focused on making that abstraction as smooth as possible. So we have a strong focus on infrastructure agnosticism, where customers have those global platforms which need to run on AWS, on Ali Cloud, and Azure. So what we are doing as a company, we are looking for the most modern, contemporary, progressive open source toolings and build a platform that we call Anynines platform that is fully equipped to run workloads at the scale of thousands or 10,000s of containers running on top of thousands of virtual machines. So the differentiation from the large vendors is not only the price, where we are, as a smaller company, also competitive, but it's also, we are not a product vendor in a classic sense, but we are shipping a software solution, and we're also offering the services, for example, the consulting that's necessary to bootstrap such an environment, and also operations to keep it going. And because often these companies on their digital transformation, they do not necessarily have a team ready to take on such a complicated technology and operate it at a scale of thousands of virtual machines. That requires experience that we bring along with automation tooling in order to make that possible.
Why is it a good idea to work with someone like Anynine versus going with the behemoth like AWS or GCP or whoever you want to call?
Well, there's nothing wrong with working with AWS. We work with AWS ourselves. It's just a question of what degree of partnership you want. Naturally, if you have a large vendor, then you'll get an enterprise experience, so to say. If you engage with a smaller vendor, such as we are, a smaller company, it's often that you talk to the CEO. It's often that you talk to hardcore engineers. You're not talking to second level or third level support. So what we do is custom tailored platforms. We help during the enablement of digital transformation projects with a strong focus on building those application development platforms. And because we are independent of the underlying infrastructure and we are not focused on a particular technology, we can always remain independent and build a framework to build application platforms that's beyond the commercial interests of those large vendors.
Since we did talk about how Anynines is helping customer, can you talk a bit about what kind of services or products do you have? Is it a mix of services that you can run leveraging SaaS, or do you also have products that one can install on their own data center, or is it a mix of both?
If you want to build an application development platform, what are the building blocks that are required? So maybe the question here. First of all, application developers want to deploy their applications. So there's a trend towards microservice architectures where applications that used to be monoliths are broken down into individual pieces. So each of these little applications, they are so-called microservices, they can be developed in their own language by a separate team, for example. This enables local choices, for example, choosing and picking the right data store to store a particular data profile versus another. So, for example, for financial transactions, as the name suggests, you may want to have a relational database where there are transactions, whereas with semi-structured data, you may want to have a document database. So if you look into the demand of application developers following those modern application development paradigms, you will find very quickly that you need to provide a home for deploying applications. And you also need to provide methods to provide databases, message queues, and other data services like that in a good and well-integrated combination in a way that the lifecycle management of the platform as well as the application workloads need to be as much automated as possible. So consequently, we looked into how can platforms be built and stumbled across those modern and popular technologies such as Cloud Foundry and Kubernetes. So these technologies, they allow you to create a home for those applications, whether you have a lot of stateless 12-factor compliant cloud-native applications, you'll have an affinity towards Cloud Foundry. Whereas if you have a larger degree of containerized applications or legacy applications with lightweight state, then maybe you have an affinity towards Kubernetes. But what these both technologies do not solve right away is, where do you get your database from? How do you run your database on top or next to such an application development platform? While in the Kubernetes era, there is a certain movement to create operators, how they are called in the Kubernetes ecosystem, we've been starting to automate database lifecycles at scale about 5 or 6 years ago. And the emerging pattern that seems to be the best choice when it comes to have one solution and offer databases from small, tiny, rather cheap databases to large production-grade, highly available clusters. The paradigm of on-demand provisioning of dedicated service instances seems to be the healthy choice. And this is what we've been doing for 6 or 7 years. So as a consequence, we today have a product framework. That's what we call the Anynines platform. And it consists of Cloud Foundry, of Kubernetes, and a set of data services, including Postgres, MySQL, RabbitMQ, MongoDB, Elasticsearch, Prometheus, an Elk stack, which is Elasticsearch, Logstash, and Kibana, so that application developers can write their application, streaming logs to a place, streaming metrics to a place where they can be analyzed again, write relational data, have a document store, and so on, have a message queue. So that makes the platform product round and complete. So this is only half the things that these clients will need, because often they are overwhelmed with operating these large distributed systems themselves. So we also offer 2 different ways to engage with us. The first would be if they have a technology team that's capable of doing that, but are not quite familiar with the technology stack. We build the deployment for them. We help them with release management, providing them new versions. They execute those releases. Or if they don't want to do that, we'll do the full remote operation. So in this way, we have had clients who were under pressure to build application platforms, and we bootstrapped environments within 2 or 4 weeks to production grade. So that's basically what we do.
Now you're also moving into the Kubernetes space. And if you look at Cloud Foundry and Kubernetes, these are now, first of all, they are housed at the same home, which is Linux Foundation. But what is happening is that customers are leveraging both these technologies. It's not Cloud Foundry versus Kubernetes. When the Cloud Foundry Foundation, they came out with their own distribution. I think it's called kubectf or something like that. But from Anynines perspective, how do you manage to maintain a balance between Cloud Foundry and Kubernetes? Because if I'm not wrong, your customers are leveraging both these technologies.
Kubernetes and Cloud Foundry are not the same. They don't solve the same problem. And that's something that is easy to overlook. If for example, you want to build your own platform and you are willing to dig into the technology, deal with different ways of networking components such as service mesh technologies, you're willing to write your own YAML specifications if you want to deploy an application. You are willing to install components, such as a service mesh, into your Kubernetes cluster and get your hands dirty into technology. Then Kubernetes is a good thing for you. It is way more flexible than a Cloud Foundry. However, if you are focused on writing applications that work and you want to delegate the heavy lifting of application operation without the involvement of DevOps, so that you'll have a team that's more focused on application development, then you need to provide them with a higher level abstraction than Kubernetes, or plain Kubernetes, so to say. And that's where Cloud Foundry is absolutely unbeatable to this day. You can deploy your applications either as containers or as using container images or using build packs, which gives you as a organization very much control over how application code is transformed into something that's been operated. So this, for example, the build pack layer is where you can also enforce company policies such as security policies. The next thing is that Cloud Foundry has an integrated marketplace where it creates a standardized interface called the Open Service Broker API that standardizes how stateful applications such as data serves, such as databases and message queues are created. So in a Cloud Foundry environment, once an application developer has gotten used to it, it's very easy to deploy an application without the help of anybody else. It's just a CF push and a CF create service, and you have a stateful application up and running. Now with Kubernetes, this is also possible, but it's way less convenient. It requires a deeper understanding on how Kubernetes works. So that's one thing. The second thing is, behind the scenes, a lot of the problems that Cloud Foundry has, for example, you deploy an application and a container is started in the background, requires a container scheduler. So you need container orchestration, and that's a non-trivial problem to solve. And over the years, Kubernetes has become more popular, and Cloud Foundry has rewritten its container orchestration several times. Because the bigger your clients are, the more of the underlying problematic actually shows, and you have to reinvent container scheduling. And I think that can be considered to some degree a solved problem now. And it seems like Kubernetes has become the de facto standard for container orchestration. Therefore, it is quite natural that Cloud Foundry carves out its own container orchestrator and integrates Kubernetes. So in the future, it is very likely that Kubernetes applications will be scheduled on a Kubernetes, so that the Cloud Foundry user experience will prevail, while the container scheduler will be Kubernetes. So there's not a contradiction at all. It's two different perspectives on application development platforms. Now, the next thing is, Kubernetes does not only cannibalize the territory of application deployment, but also, to some degree, in the territory of the infrastructures. So we've briefly mentioned OpenStack. And OpenStack has had these expectations that there is a free open source AWS software that you can set up on your hardware, which is not the case, because building an infrastructure is hard work, and you need to have the right hardware, the right networking setup, and also people who are deeply involved in getting those infrastructures to work. And then yet, you still have an OpenStack interface. To start a virtual machine, you have to talk to the OpenStack API. So this is just another infrastructure API. And if you count them, I count at least 4, 5, or 6 different infrastructure APIs. People don't want to interface with 6 different APIs. They want to describe their workloads. They don't want to take care of 6 different integrations. So I think Kubernetes, with the container movement, the way it provides an abstraction that's rather easy to describe a distributed system, has become so popular because people are fed up with solving a problem on how to run an application if that's to be done on a global infrastructure. So if at some point you push a button and you get a Kubernetes, and well, that's maybe solved, but what's not solved, that these Kubernetes clusters regardless on which infrastructure you use, provide you with exactly the same abilities. They're configured in the same way. They have the same versions. They do backup and restore in the same way. If that would be the case, then you could abstract workloads using Kubernetes. So in this regard, Kubernetes also cannibalizes in the territory of infrastructure providers. A reason why, if you look into infrastructure providers, whether it's an OpenStack vendor, whether it's a popular large-scale infrastructure provider, or whether it's a visualization provider such as VMware, they all have strong Kubernetes products because they see this trend exactly as I described it. It transforms not only the way applications are deployed, but also how virtual machines are deployed. So that's going to be very interesting, how these heterogeneities that come with those different flavors of Kubernetes are leveled out. It's something that we also investigate a lot of our time to make global platforms as smooth as possible.
You have been in this cloud space for a very long time. You have a lot of experience in the Cloud Foundry. So how does your cloud native experience from the Cloud Foundry days serve the Kubernetes customers? You have already touched upon a lot of points, but if you can just summarize it.
Both Cloud Foundry and Kubernetes address similar but not exactly the same use cases. In both scenarios, you want to deploy applications and data services. So while Cloud Foundry is a more abstract, more specific, and provides you a user experience that is more guiding the application developer, Kubernetes provides more flexibility. So our clients today, especially if they have committed to Cloud Foundry, they will keep on using Cloud Foundry because it is still a very pleasant way for application developers to deploy applications. Those clients who engage with Kubernetes now, they see challenges. For example, that there's a multitude of Kubernetes clusters. In large organizations, they could even come from various different sources. There is not very much to bring those Kubernetes clusters together, so that there's a lot more operational overhead. So when we bring Cloud Foundry clients into the Kubernetes era, we help them providing the right tool set so that they can keep on creating Kubernetes clusters and give them the tooling so that the lifecycle management of workloads, both Cloud Foundry on Kubernetes, Cloud Foundry on Borch, Kubernetes on Borch, and upcoming Kubernetes on Cluster API will behave from the operator's perspective as well as from the application developer's perspective. Yeah, I wouldn't say identical, but they should be as close as possible. So lifecycle management needs to be automated, and that's a strong focus and a challenge that need to be solved.
If you look at all these new technologies, they are coming at such a fast pace also because most of it is driven by open source, where companies, they come up with technology they put into a foundation, but that also means that your customers have, not just customers, but the users, developer community, they have to keep themselves updated with what's new going on. At the same time, the IT teams, even CIO, CXO levels, there is a lot of education they need to be fully aware of what technology they can leverage because there is so much happening. So what role does kind of education play for internal teams?
Well, I would say that software engineering has been and is a field where continuous learning is unavoidable. When I studied computer science, they said it's about the information half-life in computer science about 7 years. Or let's say in software engineering, because in computer science, there are foundations that won't go away in 7 years. But therefore, continuous learning is absolutely essential. Now, the next thing is people can actually calm down a bit because whether you look into Cloud Foundry or whether you look into Kubernetes, they're both cloud native technologies. And if you look into what cloud native means, it will all go down to, well, you want to facilitate microservice architectures. You want to store state in stateful services such as data service and keep them away from your application code. You want to make operation as smooth as possible. So, for example, You don't write into the file system because it's hard to scale a file system, so you use an object store or a database instead. If you're using a database, you ensure that the database is managed throughout its life cycle. And then it doesn't really matter whether you use a virtual machine or you use a container to do one or the other. If your application, for example, is 12-factor compliant, or cloud native, so to say, then you can basically deploy it to both a Cloud Foundry and a Kubernetes. So a developer who has learned Cloud Foundry will, say, be a natural in Kubernetes, and the other way around, because they are all following the similar paradigms in the end. The technological changes are unavoidable. You have to learn new syntax. For example, interfacing with Kubernetes is a bit different than interfacing with Cloud Foundry. But for example, if you take the automation that Bosch does, like being declarative, where you declare a distributed system, hand this declaration and this description over to Bosch, and it will then carry it out by creating the resources. This is pretty much the same what Kubernetes does if you handed out a specification on how your stateful set should look like. If you describe how your application deployment on Cloud Foundry should look like, for example, that many application instances of that app, that many application instances of the other app, it's pretty similar to what you do with a deployment in Kubernetes. So the methodology is similar. The architecture is similar. The patterns as a developer you have to use are basically the same. And then, to some degree, the syntax will be different in how you interact with these systems, but that shouldn't be a problem. If you learned one of the two, you'll naturally pick up the other one.
Anynines also does a lot of work to help educate customers. Can you talk about some of the efforts and that are going on at Anynines itself?
If a client wants to digitally transform and introduce application platforms, this is usually a stage where we are getting involved. We are helping clients to find out what is the platform stack that will work in a particular scenario. I'll just give you an example. If a client has a strong relationship to an infrastructure provider, may it be Google Cloud Platform or AWS or Azure, that's nothing we would interfere by dragging him from one infrastructure to the other. But we'll help him to get the application platform up and running on this infrastructure. If a client, on the other hand, wants to bootstrap a global application platform environment and therefore needs different infrastructures, we'll help them to choose and pick the right tools to make that possible. And usually this involves naturally some kind of enablement. So sometimes these clients already have very good teams and it's a good cooperation right from the beginning. And sometimes these teams are new to this era of cloud native environments and therefore need more guidance. In those cases, we do trainings. This is not a major product we offer. We sometimes also do custom software development, developing service brokers, which is one of our, strong sides, or develop CI/CD pipelines to bring the releases that we ship as solutions into their environments. And this helps to bridge the gap between having a product downloaded into a infrastructure environment and get it running, because there are also a lot of organizational hurdles people have to overcome. For example, often these hurdles are not outside of the company, but they are inside of them. So let's say security. When the first time an application platform is introduced in a large organization, there's going to be a nightmare of discussions with security folks to get those platforms approved. So we help them to organize such internal approvals by, for example, going through the network layouts, talking about how can security scans be integrated in the release management process, so that all those check marks these organizations need to get a system into production are actually done. So this is not about selling a software license and just walk away, as some vendors try to imagine that business. It has inherently a professional services part. And that person that you that you want to engage, they not only should bring you the software, but they should also know how to use it and show you and help you to overcome these initial barriers.
Thank you, Julian, so much for taking your time out and sitting down here today and explain all these intricacies about Cloud Foundry, Kubernetes, and also the role that Anynines is playing to help customer embrace both of these technologies. And I look forward to talk to you again. Thank you.
Oh, thank you very much. It's always a pleasure.